In this segment, we'll use the ideas from the prior two segments to declare increasingly complex types. Now, let's go one by one through the declarations, starting on line 51 and running through line 56 in our example program here. As the comment above them indicates, you should provide an English description for each of them and show a valid initialization of the variable using existing declarations from above up here. There's all the material you need above to do that. We'll do an in-lecture question for each of them. So, question 1. What is being declared on line 51, and how might we initialize it? And returning from a pause, the declaration implies that it would first be indexed, since the bracket will occur first, and then be double starred. So I guess that would make it an array of 2 double pointers to ints. It's an array first of double pointers. And I suppose we could initialize it by taking the addresses of maybe P1 and P2. That would be double pointers to ints. And so an appropriate initialization might look like this here, with braced pair ampersand P1 ampersand P2. All right, so let's move to question 2. What's being declared on line 52? And how might we initialize that one? Again, returning from a pause there, the declaration says that you'd first dereference V1 and then index it twice to arrive at an int. Thus, it's a pointer to a two-dimensional array of ints of size rows by cols. Now, image, as it turns out, is just such a pointer, or just such an array. And so all we really need to do is take the address of that, and we'll be good to initialize it. Thus. And question 3. What type is V2, and how would you initialize it? Well, the declaration, coming back from a pause, the declaration says to index it twice, and then dereference the result again twice. So it must be a two-dimensional array of double pointers to ints. I suppose we could initialize that by using the addresses of our P1, P2, and P3 single pointers, and maybe repeatedly using them so we can get a total of 6 of them, like that. And question 4. What's being declared on line 54? What is V3? And how might we initialize that one? And returning back from a pause there, this one's rather more complex with some parentheses. The declaration says to index it first, then dereference the result. So it's an array of 2 pointers, I guess. But what's the result of the dereference? Well, apparently it's something that we want to index again, and then dereference the result of the index to arrive at an int. I guess that would be an array of dim int pointers. So finally then, in all, we have an array of 2 pointers, 2 arrays of dim pointers to ints. Well, let's see. Variable array of pointer is, as it turns out, an array of 2 pointers to ints. So I guess we could use its address twice to initialize array V3, and we'd get something that looks like this right there. And of course, question 5, what about line 55? What is being declared, or what is V4 being declared as? So returning from a pause, and I'm going to leave this full-sized font in the transcript as well because it's pretty lengthy. So let's see what we got to do here. We first are going to dereference V4, and then apparently we call the result of the dereference. That's a big long parameter there in parentheses. So it's a pointer to a function. But what parameter type? Well, that's pretty complex in its own right, so let's sort of break that out separately here. There we go. And that's our parameter. Then it's also in the transcript, of course. Now, this is a pure type, and a variable name would go right there after the first star. And if we added the variable name, we'd have a function pointer declaration. Indeed, one just like f_2 on line 39, if you look at it. And this, by the way, is not to be confused with v4, which is a function pointer in its own right, of course. Now, this function pointer that we're dealing with here takes as its parameter a pointer to an array of calls ints. One could pass image to this, for instance. So then, v4 is a pointer to a function that takes as its only parameter a pointer to a void function that takes as its only parameter an array of calls ints, a pointer to an array of calls ints. Okay, but we're not done yet. What does v4 return? Well, apparently we double dereference whatever it is and then get an int. So the return type is a double pointer to int. Thus we have, take a deep breath, a pointer to a function that takes as a parameter a pointer to a void function that takes as a parameter a pointer to an array of calls ints, and that returns a double pointer to int. Now, do we have such a function lying around anywhere? Yeah, as it turns out, conveniently, function A up here on line 23 fits the bill. There it is. It takes as its only parameter a pointer to a function that takes a pointer to an array of calls ints, and it returns a double pointer to int. So we could initialize, thus, v4 simply with the address of function A, or just the name function A itself, which is the same thing. And there we are. Now, question 6. What, finally, is being declared on line 56? What is v5? And how might we initialize it? All right, turning from a pause, it looks like v5 is dereferenced and then called with no parameters. And the result of that call is in turn dereferenced. This leftmost star is dereferencing the result of that parameterless function call. And then the result of that is again called, this time with a parameter that's another one of those pointers to an array. So we have a pointer to a parameterless function that returns a pointer to a function that takes a pointer to array parameter and returns nothing because we have void over here. Well, of course, conveniently up here, function B is just such a function. Its header indicates that it is passed no parameters, empty parentheses right after it. And then if we dereference its return value, we can call the result as another function, passing a pointer to array, and ultimately getting back void. And as you can see on line 28, it returns read array, which is the address of a function that takes a pointer to a array and returns void, just as you'd expect. So in the final estimation, then, we can initialize v5 using func b. Now, I expect at this time you're probably sick and tired of this and hoping it will be done, but not a chance. If you need to go get a cup of coffee and resume the lecture afterward, that might be a good idea. We are now going to write complex types after having tried our hand at reading them. I'll provide an English description, and you write the type. Name the variable a in each case, and as before, do your best to come up with the answer before looking at mine. Some traps to avoid, just as a warning. Don't fall into the left to right pattern. You'll be tempted to just write out the declaration left to right, matching the English. Remember to do inside-out logic, where each new step is applied outside the existing expression, either on the left if it's a dereference, or on the right if it's an index or function call. And then hint number 2, don't be intimidated by the parameter pure types. Just think of them as a sub-problem within the larger problem and solve them independently. Leave a placeholder for them, if you like, and then go back and fill in the pure types after the big declaration is done. And then number 3, don't try to jam a function return type to the left of the function pointer declaration. Remember that you wrap it around the function call. Okay, with that in mind then, question 7. Declare a 10-element array of double pointers to 5-element arrays of ints. And returning from pause there, well, let's see. Kind of building this inside out to show you how it might be done. Since it is an array, the first thing we do to it would be index it, and we'll put the dimension 10 in there. And then we dereference the result of that twice, since it is an array of double pointers. And then the result of that, need parentheses for precedence, we would index yet again. And the result of that would be an int. So, put int ahead of it, and that's what we get. Okay, so let's try another one. How about a 5-element array of double pointers to functions that take 2 int parameters and return a pointer to an array of 10 integers? And returning from a pause, we'll do this one again step by step as in the notes. So let's see here. It's a 5-element array, so we will index it. And the result is a double pointer, so we'll star that twice. 5-element array of double pointers. Now, the double pointers are to functions, so the next thing we will do is call that, and apparently they take 2 int parameters using pure parameter notation there. We get what we're looking for. So a 5-element array of double pointers to functions that take 2 int parameters. Now that function is supposed to return a pointer to an array, so we're going to parenthesize. Well, I guess we don't have to parenthesize just yet, but we're going to add pointer. So function that takes 2 int parameters and returns a pointer, and then parenthesize that because it's a pointer to an array, and then index the result of the dereference by 10, since it is a pointer to an array of 10, and finally we're down to an integer, an array of 10 integers, and the declaration looks like that, leaving us with an array of 5 double pointers to functions that take 2 int parameters and which return a pointer to an array of 10 ints. What could be simpler? Well, I don't know what could be simpler, but I can tell you what might be even more complex, which would be question 9. Now declare a double pointer to a function that accepts a pointer to a function that takes 2 floats and returns an int, and which returns a pointer to a function that takes 2 floats and returns an int. That one's even hard to parse as an English sentence. Read it carefully. And returning from a pause, we will build this one inside out, starting with a double pointer. A double pointer to a function. Now the parameter is a sort of a subroutine, right? So kind of off to the side a little bit, that parameter is a pointer to an array of 5 ints. Let's see, we know how to do that by now. P looks like that. And then of course the pure type is that. And so that's what we'll put in the parentheses here. And we now have a double pointer to a function that takes a pointer to an array of 5 ints. And it returns, according to the description, a pointer to a function. And this function takes 2 floats. And so now we have a double pointer to a function that takes a pointer to an array of 5 ints and returns a pointer to a function that takes 2 floats. And that one returns a pointer. And that is finally an int. So we thus have a declaration of a double pointer to a function that takes a pointer to an array of 5 ints and returns a pointer to a function that takes 2 floats and returns a pointer to int. Do you recognize this one? It's the nasty declaration we started the first segment of this topic with. So we've come full circle. I'm hoping that at a certain point, perhaps already, you just get the flow of these. Once you do, you can take any arbitrarily complex declaration and just write it out. And the difference between int star a10 as an array of 10 int pointers and int parenthesis star a10 as a pointer to an array of 10 ints, that difference will never bother you again. Now, reading pure types is a special skill of its own, so we'll do one last question. The extra challenge, of course, is to find the spot where the variable would have appeared. Once you have that, it's like reading a normal complex declaration. This can be compounded by a pure type that includes other pure types within it as parameters of function pointers. So let's try just one exercise at this. What type is the following thing? And that is question 10, by the way. So, coming back from a pause. Well, the main variable would go just after the fourth star right there. So that's our A. And there's also an inner pure type over here. And its variable, we'll call it P, would go after the fifth star there. So, the type is the overall type, a pointer to an array of 10 pointers to a function that takes two parameters. The first parameter is a pointer to a function that takes an int and returns an int, and the second parameter is just a simple int. Now this second function returns a double pointer to an int because the first two stars, if you read the grouping carefully, apply to the result of the function call. Now, if you follow all this, and if you got most of the in-lecture questions right, then you fully understand C declarations, which probably puts you above 75% of the C experts in the world. Congratulations.